Today we're working on learning target 3 again. Now, learning target 3 is direct substitution. So before, that was really simple. We just substituted values into the function and it worked out for us. But today we're talking about functions that direct substitution works, but not until you kind of simplify the function. All right? So today we're going to factor, use conjugates, find common denominators. It's going to be all sorts of things we have to do to simplify these. All right? Once we simplify them, we'll be able to use direct substitution. They're just going to take some more work and take some extra effort. Okay? So 3 examples here, and there's one more after that, but 3 on the screen. So on the first one, I have a limit as x approaches 2 of 2 minus x over x squared minus 4. If I try to directly substitute, I would get 0 over 0. That's bad. You can't divide by 0. This is a problem. So again, direct substitution does not work there. So I need to simplify this function if possible. So I have 2 minus x over x squared minus 4. In the denominator, I notice you have x squared, so it's a quadratic. It's probably factorable. It's actually a difference of 2 squares. So I'm going to factor, Mr. Scott calls it LOIF, the denominator. So I have x minus 2 times x plus 2. Okay? It would be nice if I could cancel some things out, but right now I cannot. Even though 2 minus x looks a lot like x minus 2, it's not the same thing. So I'm going to keep rewriting until I can cancel some things out. This 2 minus x, if I rewrote it so that x was in the front, I have negative x plus 2. Again, that's still not the same thing. All right, that's not the exact same. So maybe I need to take a step farther, because I need to be able to cancel something out for this to work. So if I take a negative out, I have a positive x minus 2. If I distribute that negative, I get the negative x plus 2 I had before. And that's over x minus 2 times x plus 2. And now I have 2 terms that are the same that I can cancel out. So I have a brand new function, negative 1 over x plus 2. This is an equivalent form of what we started with. It's just simplified. So now, if I want to find the limit as x approaches 2 of this function, I can. Because now I just substitute 2 in for x and nothing weird happens. Get negative 1/4. This is the perfect example of when direct substitution doesn't work initially, but you can work with the function to make it work. All right, so factoring. Factoring is going to keep coming up over and over and over again in this mini unit. All right, the next one. The limit as x approaches 0 of this big function. If I put 0 in for x, I'm seeing big red flags. That's a big problem, because I can't divide by 0. Now this one's kind of messy. So you have the square root of 2 plus x minus the square root of 2 all over x. I can't do anything with the denominator. The numerator, I can't subtract those radicals. But what I can do is when I see radicals, maybe I should use the conjugate, because I know that when you multiply 2 radicals, that we can multiply what's underneath and take the square root, and it all works out for us. Okay? So we have the square root of 2 plus x plus the square root of 2. Square root of 2 plus x plus the square root of 2. Remember, our conjugate is what you had with the opposite sign. Now, what does that opposite sign achieve? Technically, you are supposed to FOIL, multiply all of these terms together. But because of the opposite signs, the middle terms drop out. One will be positive, one will be negative. They'll be the exact same thing, and so they cancel each other out. So I'm technically FOILing, but I'm not going to do the middle terms. All right? Don't forget that that is part of something when you multiply, though. So I'm going to do the square root of 2 plus x times the square root of 2 plus x. Now, if you do this, you are technically it's multiplying what's underneath the radical. 2 plus x times 2 plus x, which you would have to FOIL. Right? And then I would get a quantity squared and the square root, and it cancels out. So with all that being said, we just get 2 plus x when you multiply the square root of 2 plus x times the square root of 2 plus x. Another way to think about it is thinking about it with exponents. This is really 2 plus x to the 1/2 power times 2 plus x to the 1/2 power. And if you're multiplying two things, you add the exponent. And you have 2 plus x to the first power. So that works as well. Then again, the middle terms are going to drop out. So I could multiply first times last and inside times inside. But you're not going to get those terms. One's going to be positive, one's going to be negative. They're going to drop out. So I'm not going to worry about it. And then I'm going to multiply the last terms. So again, you have negative square root of 2 times positive square root of 2, so we get a negative answer. Square root of 2 times the square root of 2 is just 2. Again, you're multiplying what's underneath, so this one's easy. 2 times 2 is 4, and the square root of 4 is 2. So again, if you think about it, the square roots don't just go away, it's just simplified, okay? So the conjugates make this look messy, but we end up with this really simple answer here on the numerator. In the denominator, I am not going to distribute this. I'm just going to write it as two separate things that are being multiplied. All right? Now, I need to simplify a little bit. In the numerator, I have 2 minus 2. Well, that's 0. So I have x over x times the square root of 2 plus x plus the square root of 2. Well, now I have an x in the numerator and an x in the denominator, so I can cancel those out. That leaves me a 1 in the numerator. So I have 1 over the square root of 2 plus x plus the square root of 2. Now, this looks messy. You're looking at me saying, oh my gosh, we just did all that work and now I have all these radicals in the denominator. But remember, we're trying to make sure we can use direct substitution and find limits. So if I try to find a limit as x approaches 0, we shouldn't have any issues anymore now. Because now when I substitute in 0, I have the square root of 2 plus 0 plus the square root of 2. Well, 2 plus 0 is just 2. So I have 1 over 2 square roots of 2. All right? So you don't have to rationalize that. We have 1 over 2 square roots of 2. That's fine. We have directly substituted now by using conjugates. You're going to have to use conjugates a whole lot in this section. Again, when you're getting lost, ask me questions, look at my homework, see if we can figure it out. Last one on this page, on this slide. Again, we're looking for the limit as x approaches 0, but if I put 0 into the denominator, we're dividing by 0, so that's an issue. Now I'm going to rewrite this without the brackets. So we have the function 1 over x plus 4 minus 1/4, all over x. I need to simplify the numerator. I need to actually be able to subtract those two fractions. But to subtract fractions, we have to have a common denominator. So that's what I'm going to do first. To get this common denominator, I'm going to multiply by the opposite denominator. So we'll multiply the first fraction by 4 over 4 and the second one by x plus 4 over x plus 4. That way I guarantee I get a common denominator. So all this again is happening in the numerator, so we still have this division by x down here at the bottom. If I multiply, I end up with 4 over 4x plus 4 minus x plus 4 over 4x plus 4, all still over x. But at least now I have a common denominator. So now that I have a common denominator, I can actually subtract. So I have, in the up here, all up here, I have 4 minus x plus 4. Make sure you use parentheses so you don't forget to subtract something. Over 4 times x plus 4, all still over x. Looks like this could be simplified a little bit. This is really 4 minus x minus 4. So 4 minus 4 is 0. So I have negative x over 4x plus 4, all still over x. I know this isn't looking very nice, but this is really x over 1. So what we can do is we can multiply, because we have a fraction divided by a fraction, so we can multiply by the reciprocal to simplify this. So I have negative x over 4x plus 4 times 1 over x. But when I do that, I can cancel these x's out. So now I just have negative 1 over 4 times x plus 4. So now I'm trying to find the limit as x approaches 0. If I put 0 in, I shouldn't have any problems. So if I look for the limit as x approaches 0, I have 4 and 0 plus 4. That's 4 times 4. So I have negative 1 over 16. That's my limit. Was it a pain to get there? Yes, but I did it. So you used common denominators and used algebraic properties in order to find the limit. Okay? All right. One more example. The limit as delta x approaches 0 of this function. Now, here's what you have to know. Delta x and x are not the same thing. It's like having two variables in this problem. Okay? So it says delta x approaches 0. That means wherever I see a delta x, I would put a 0. And so if I put a 0 in the denominator again, I can't do that. That's a problem. Now in this function, I just see that I have this squared term, and hopefully if I just like work that out, maybe some things will happen so I can directly substitute. So I have x plus delta x squared, which means x plus delta x plus delta x minus x squared, all over delta x. So I need to FOIL this. Once I do that, maybe some terms will drop out. Maybe I'll be able to cancel some things out. But hopefully we'll be able to simplify it. But you have to FOIL it first. So x times x is x squared. X times delta x is just x delta x. Again, they're not the same thing. Having x times y, you get x times y. Well, here we get x times delta x. Delta x times x is another x delta x. And then delta x times delta x is delta x squared. Then we still have this minus x squared to tack on, and it's just all over delta. I know it looks messy. Just doing some algebra. So now we need to simplify. I have an x squared minus an x squared. So that's 0. Right? X squared minus x squared, 0. I have a x delta x plus x delta x. That's just 2 of them. So I have 2x delta x. And I still have this plus delta x squared. This is all over delta x. Now, I still haven't eliminated the delta x in the denominator, so I still have a problem, because I still can't put 0 into the function. But I see a delta x in every single one of these terms. So we're going to have to factor. So if I take a delta x out of the numerator, I'm left with 2x plus a delta x, right? I take a delta x out of this term. I have 2x left. I take a delta x out of this term. I have a delta x left, right? So I've factored one out. I still have the delta x in the denominator. But now, I can cancel these delta x's out. So now I'm just looking for the limit as delta x approaches 0 of 2x plus delta x. And so now when I put 0 in, I have 2x plus 0, and I have 2x. There isn't going to be a numerical answer here because we have two different variables, x and delta x. So you have 2x as your limit. That's just algebra. We had to multiply two binomials. We had to factor a term out of the numerator. We had to cancel something out of the numerator and the denominator so that we could find the limit. So take your time on these. Use these ideas. I've covered pretty much any idea you would need in order to answer the questions in the homework. Factoring, big thing. Be able to factor. Use the conjugate if you see square roots in the numerator or denominator. Try to find common denominators if you have fractions trying to add and subtract. All these are generally set up for you to use one of these methods so that everything shakes out and you can use direct substitution at the end. All right, so this is going to take some practice because I know it's hard. All right, so get to it. Learning Target 3, Day 2.